How can capitalism exist in space? What will be commercially successful first, Earth orbit or the moon? Did we observe lightning on other planets? And in Q&A Plus, could aliens be watching Earth as a reality TV show? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get to the questions. Todd Ablett, which comes first, a commercially successful moon base or a commercially successful space station? I think we'll have a commercially successful space station first before we have a moon base. There are a couple of commercial space stations in the works right now that we should see launching within the next couple of years. We've seen some commercial tourist flights. And so you can imagine that millionaires and billionaires are going to want to go to a private space station and float around in space for a week. And they'd be willing to pay tens of millions of dollars to do it. Setting up a base on the moon is going to be really hard. That is going to take some of the best, most knowledgeable people to be able to do that. And then there will be commercial entities that will try to do that as well afterwards. Maybe, or maybe the commercial people will come first. I don't really know. But right now, I think anticipate a space station that the billionaires can go play in first before you see a base on the moon that the billionaires can go play in. P0tato Biden, how can capitalism exist in space? I mean, the way capitalism exists in everything, which is that people think they can make money from it. And so they invest in some endeavor and then they see a profit and then they reinvest that profit into it and then they keep growing their company. So, I mean, obviously we have telecommunication satellites, Starlinks, right? So people are making money from putting things in space. We have weather satellites. We have Earth imaging satellites. Right now, our entire space economy is focused on supplying services to the surface of planet Earth from space. But that's the beginning. And then you can imagine some future where somebody is able to make a profit on mining an asteroid. And then suddenly you've got a whole new mining in space will work like mining on Earth happens. Now, it's going to take a long time, right? Like right now, the cost, is a huge money losing gamble, but maybe in the far, far future, someone will figure out or have enough infrastructure that it does make sense to do space mining. Maybe, you mine your resources and you send them to fuel depots, not back to Earth. But still, you can imagine somebody coming up with a business model that will then continue on into the future. One, can you imagine the Chinese landing on the moon? Sure. The Chinese are testing their new heavy lift Long March rocket right now, and they are they just recently tested their lunar lander component. They did a drop test and a full fire of its engine, and that all seemed to go well. So in 2030, they're going to send 2 rockets to the moon. One rocket is going to carry a crew capsule, and then the other rocket is going to carry the lander. And then the lander and the crew capsule will meet up in lunar orbit. They'll dock, and then the crew will get into the lunar lander while the capsule remains up in orbit. The lander will go down to the surface of the moon, and then they'll get out and they'll do a bunch of science on the moon, and they'll get back into their lander, and then the ascent module will pop off the top of the lunar lander, go up and meet with the capsule in space. They'll get back into their capsule and then they'll return to Earth. So it's very similar to the Apollo mission, except instead of it all being in one big rocket like they did with the Saturn V, it's going to be on 2 heavy lift rockets that will meet up at the moon, which is a pretty elegant solution for the problem. And, at this point seems like a more elegant solution than the SpaceX solution, which is to send 15 to 20 starships to refuel in space and then go out to the moon and then use a Starship as a lunar lander, which is supposed to happen in like 2 years now at this point. So, it's not. It's going to be delayed. Church discography. Has extraterrestrial lightning been observed yet? On Jupiter, but not on Venus. I think people thought they saw lightning on Venus, but it hasn't been confirmed. And lightning on Mars in the dust storms? So probably not on Mars, and theoretically on Venus, but not seen. So Jupiter is the one. There are images of lightning on Jupiter captured by the Juno mission. So the only place that we know of for sure where there is lightning outside of Earth is on Jupiter. Probably Saturn, Uranus, Neptune. Redhead Roadtrip. Would astronauts at the South Pole be always protected from solar storms or always vulnerable? Yeah, it depends. If you're in the shadow, then you're protected. And if you're in the sunlight, then you are vulnerable. Michael Boulos. If the universe is infinite in size, does that necessarily mean that every possibility, no matter how unlikely, including an exact duplicate of you living on a planet called Earth, exists elsewhere? So this is the idea that there are a finite number of configurations that matter and energy can take in a volume of space. That if you take a cubic meter of space, there's a finite number of ways that you can have sort of quantum configurations in that cubic meter. I forget the number. It's like 10 to the power of 80 or something like that. So it's a large number, but it is a finite number. And in an infinite universe, then finite numbers do very weird things, because you can essentially have a finite number repeat an infinite number of times in an infinite universe. And so if you go far enough, like say you take one just chunk of space, 1 cubic meter of space, and measure all of the quantum states of everything inside that cubic meter of space, and then you go some giant distance, you'll see lots of different cubic meters of space, but eventually you'll find a repeat. It's kind of inevitable of something. And then you go farther and you find repeats of larger than just 1 meter, 2 meters, 10 meters, 1,000 meters, 1,000 kilometers. And so theoretically, not only will there be a repeat of Earth, of me giving a live stream on this other Earth, there will be a repeat of the entire Milky Way. There will be a repeat of the entire observable universe, right? Infinity gets pretty weird when you think about it. So, we don't know if we live in an infinite universe or a finite universe. That's still sort of one of the outstanding questions that astronomers have. But if it is an infinite universe in space, then the things can get pretty weird. And you can have an infinite universe in time, right? Into the far, far future. That we know that quantum states can change over, in unpredictable ways. Mostly, the atoms will be where you're expecting them to be, but every now and then they'll be somewhere where they're not expecting to be. And if you wait long enough, then larger and larger numbers of atoms will rearrange themselves in ways that are new configurations. And so you can not only imagine those repeat cubic meters in space, but you can imagine those repeat cubic meters coming up in an infinite amount of time. So if you have an infinite time in the future or an infinite space, then you can have weird repetitions show up. Now, the key here always is it has to be something that's possible. So you can't have things that are impossible, right? So you can have, we look around this world, look at the things that we see. Those are things that are possible because they happen once, but you won't necessarily be able to get magic, right? If it's a thing that's impossible, then you won't get that. You'll just get things that are possible.
It's time to shout out all the new $5 patrons and above. Methel, Twizzy, Willie Schweigert, Jim P., Tom Hildebrandt, Robert Denham, Joshua Lowry, Maltia, Daniel Gilligan, and Jovica Popovich. Join the club at patreon.com/universe today.
Snarzetax. Have you looked at the Timescape cosmological model? What do you think of it? I always give this disclaimer at the beginning of every live stream that I do, which is that I am a journalist, not a scientist. I don't have opinions about these kinds of things. I have done some reporting on the Timescape model. It's been a couple of years now, but the gist is that astronomers consider the large-scale structure of the universe to be largely homogeneous, that no matter where you go randomly in the universe, the amount of material that's around you is going to be roughly the same, like to 1 part in 30,000, if I remember correctly. So it doesn't matter where you go, everything is going to be roughly the same. Now, sometimes you will be at the center of a star or the center of a planet, but most of the time you won't be. Most of the time you will be in intergalactic space, you'll be in interstellar space, you'll be out there in the cosmos, and things are going to look kind of the same. But a team of astronomers have proposed that homogeneity is not true. That in fact, when you go into the larger, more dense regions of the universe, the places where you have, galaxies, galaxy clusters, galaxy walls, the sort of large scale collections of galaxies, then those parts of the universe are actually going to be significantly denser than the voids and other parts of the universe. And if so, then you're going to get different amounts of time dilation between the places which don't have a lot of mass and the places that do have more mass. Think about the movie Interstellar, right? When you get close to the black hole, then you experience time dilation because you're in the presence of a large mass. Now, it's going to be subtle, but over the course of billions of years, those differences add up. And that explains dark energy. It's not that we are seeing the universe accelerate over time, the expansion of the universe accelerate over time. It's that we are seeing parts of the universe that are experiencing time at different rates. And that, according to them, they do the math, it fits better for the explanation of dark energy than this idea that, in fact, there's some intrinsic nature of the universe that is accelerating its expansion. And recently, dark energy has been sort of turned upside down. When the accelerating expansion of the universe was first discovered in 1998, astronomers weren't looking for this. This was an accident. They were trying to calculate how the expansion of the universe was going to slow down over time. It's assumed, right, that all this mass, there was the Big Bang, everything's moving away from itself, but eventually, right, the mutual gravity of everything is going to slow it all down, and eventually it will come to a stop. And they maybe even collapse in on itself. And astronomers are trying to figure out, what is that point? Will it expand forever? Will it coast to a halt at an infinite amount of time? Or will it actually start to collapse in on itself and lead to the big crunch? And what they found when they measured the sort of the changing expansion rate of the universe over time was that it seems to be accelerating. And again, that was a surprise. Nobody asked for this, right? This is not a fudge. This is not a theory. They went into it with no expectation that there was going to be this weird result. And yet there it was. And the more supernovae that astronomers detected, the more of these that they found, the more this idea was confirmed. And so whenever you have a mystery like that, you figure out what is the best way to study it to answer these questions. And so we got the DESI survey, the Dark Energy Spectroscope instrument, and then we got the Euclid mission, we got Vera Rubin, we've got Nancy Grace Roman coming up. Like, all of these instruments, their job is to measure the universe at different times in its past in different ways. And then we can get this really good idea, this really precise information about what the universe was doing at different phases. But the first one to release its results from DESI found that the universe appears to be, that the amount of dark energy is changing over time. That instead of it being this sort of smooth addition of dark energy into the universe at set amounts of time, that maybe it's actually changing as well, decreasing over time, which is kind of good news because, like, one of the big concerns, like, what if dark energy is increasing? That's how we get the big rip. So if dark energy is decreasing over time, then eventually maybe it'll just go away. And so when the Timescapes model was released, it sort of was well timed with the DESI survey first result. And they felt that their explanation was a better answer, fit the math better, fit the observations better. But we are just in early days of this. And so, until we get this proper answer from Euclid, from Vera Rubin, from Nancy Grace Roman, from DESI for years and years and years and years, it's all still too early days to have any kind of definitive answer. They think the math works. Other people think the math doesn't work. It's too early to tell.
Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. And this week's bonus question, could aliens be watching Earth as a reality TV show? I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank you, everyone who put your questions into the YouTube comments. Everybody who joined me for the live show. Now, we're still on hiatus on our live show, back in about 2 weeks. So I'll put the next show in the calendar, and that's when I'm going to be back in Canada, back in my studio, and able to do a live stream again. Now, I'm going to talk about epistemology, which is, fairly philosophical topic. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Barely Griffin, Brian Bodie, Carrick, Chuck Hawkins, Commander Baylock, Cy Nielsen, Dark Finga, Dave Verbaugh, David Giltonen, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Roebuck, Ryan Kaidu, Richard Williams, Sean Sargent, Stephen Fowler Munley, Team 49, Telescopes Canada, and Wolfgang Kloss, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So in the last week's question show, I talked a bit about how, people are it's interesting to me how people are outraged by the concept of the scientific consensus. And I think, and then I said that this was very much evidence that there are people who are trying to sort of wear away and remove people's acceptance of expertise. That suddenly now somebody being an expert at something is seen as a downside, which is very peculiar. It's very bizarre, right? That the person who is most qualified to work on some topic, to provide you information about something, is the person who's dedicated their life to that thing. And somehow the sort of the forces against expertise. And I really do feel like, I'd be a conspiracy theorist, but there's real value in eroding people's trust in expertise, because if you can't trust anybody, nothing is real. It's a very cynical perspective. And yet, we all know what it feels like to be an expert in something, to have a range of, a video game that you know a lot about, that you've spent a lot of time, you're ranked in how well you play that video game. And if, you listen to someone talking about that video game and you're like, that's ridiculous. The person doesn't know what they're talking about, right? That is what it feels like to be someone who is an expert in climate science, virology, astronomy, space exploration, so on, and to listen to people who are making up straw man arguments about things. So I think the thing that's most important here is, for all of us, for everyone, is to think a lot about epistemology. And this is just the idea of, how do you know what you know? What is the mechanism, the method that you use to derive truth from falsehood? Anyone can say something. You can say it on the internet, you can say it on Twitter, you can say it on the blog, you can say it in a science journal, you can say it on the media, you can say whatever. And that then it's our job as people who are trying to decide, creating a filter, decide what gets into our brains or not. How do we decide what gets into our sort of consciousness that we can provisionally accept as being closer to reality than not, right? Is coffee good for you? Is coffee bad for you? Is exercise good for you? Is exercise bad for you? Is saturated fats good for you? Is saturated fats bad for you? All right. Did we land on the moon? Did we not land on the moon? Right. Those are the examples of things that we need to know. And some of them are just frivolous, right? Others have a real world impact on your life, on your health, on your future. And so it's really important to come up with a method of having a good epistemology for how you decide what is true and what is not. And, the best way to figure out whether something is true or not is to become an expert in that field. In other words, to go and put in the time and research to be able to understand the current state of the literature. And when you become an expert in that field, like say you want to become an astrophysicist, you want to understand black holes, you want to understand dark matter, dark energy, whatever, then you are kind of going through the historical literature of every single thing that anybody has ever learned about that topic. And all of the paths that led to dead ends. Maybe dark matter isn't real. Maybe dark matter is just neutrinos. Maybe dark matter is, that we don't understand gravity at the largest scales. Like there's a whole lot of these different pathways that people go down, and that you will learn all of those pathways. So that when somebody pitches some idea to you, says, well, maybe dark matter is just rogue planets. You'd be like, whoa. We thought of that. We looked into that, and here's the problem, right? And so you can understand. But we can't go and become an expert in more than just a couple of fields to that level of depth that, that would take you a decade of your life to really deeply study. And yet, and I've been saying this for a couple of weeks now, I want to sort of impart on you that that's the level it takes to have a serious opinion about a topic, is to have put in the decade to become an expertise, the 10,000 hours, the getting your PhD, or that level of study. And that's the point where you now are in the cutting edge, and now you understand the entire sort of knowledge space, and then you can help make progress into the future. And that when you shortcut that process, because it feels right, feels good in my gut, like I don't need to understand virology because I get it, like I just feel right. But that's the way that humanity stalled for thousands of years, is that we trusted our gut over the scientific method. It's only when we trusted the scientific method did we start to make serious progress and have this modern life all around us. And that sort of concept holds to this day and continues on into the future. And so you've really got to sort of reject that instinct to just trust your gut and instead spend the time to become an expert. And if you don't have the time to become an expert in all of the things, then look for the person who just did. Look for the person who put in the time to become the expert. The person who put in the time to become a mechanic. Are there bad mechanics? Of course. But there are also really good mechanics, right? And it's easier to know who is a good mechanic versus a bad mechanic than it is to become a good mechanic. It's easier to know who's a good scientist than to become a scientist. It's easier to know how to know who knows things well, who has good epistemology, than someone who doesn't. And it's easier for us to do that, to trust somebody else, than to try and do it ourselves. All right, we'll see you next time.